Hello dear students. Let's study the concept of mass and weight. Mass is the amount or quantity of matter contained in an object. The mass of an object is the measure of its inertia. That means greater the mass, greater is the inertia. Mass of an object remains the same whether the object is on the earth, the moon, or even in outer space. Thus, the mass of an object is constant and does not change from place to place. The SI unit of mass is kilograms. Weight. The weight of an object is the force with which it is attracted towards the earth. This force depends upon the mass of the object and the acceleration due to gravity. So, we can write that F is equal to mass into G, or we can also say that W is equal to mass into G, where G is the acceleration due to gravity. At a given place, the value of acceleration due to gravity is constant. Therefore, at a particular place, the weight of an object is directly proportional to the mass. That is, we can say that W is proportional to M. The SI unit of weight is Newton. What is the difference between mass and weight? As we have already studied that mass of an object is the measure of its inertia. That is, greater the mass of an object, greater will be its inertia. Whereas, weight of an object is the force with which that object is attracted towards the earth. The SI unit of mass is kilograms, whereas the SI unit of weight is Newton. Mass of an object is constant and cannot change from place to place, whereas weight is not constant and weight changes from place to place. Mass has only magnitude but no direction, whereas weight has both magnitude as well as direction. Weight of an object on the moon. We know that the weight of an object on the earth is the force with which the earth attracts the objects. Similarly, we say that the weight of an object on the moon is the force with which the moon attracts that object. We know that the mass of the moon is lesser than that of the earth. Due to this, the moon exerts lesser force of attraction on objects. Let us take an object having mass m. Let its weight on the moon be Wm. Let the mass of the moon be represented by mm and its radius be rm. If we apply the universal law of gravitation, the weight of the object on the moon will be Wm is equal to capital G into mm into small m divided by rm square. If we consider the weight of the same object on the earth, then that weight would be represented by We. Let us consider the mass of the earth m and radius r. So the expression becomes We is equal to capital G into capital M into small m upon r square. If we substitute the values of mass, radius and gravitation constant, we get Wm is equal to 2.431 into 10 raised to power 10 G into M, and We comes out to be 1.474 into 10 raised to power 11 G into M. If we divide Wm and We, we get 0.65, or we can also write that the ratio of weight of the object on the moon to the weight of the object on earth is equal to 1 by 6, or we can also write like this: Wm is equal to 1 by 6 into We. That is, the weight of the object on the moon is 1/6 times the weight of the object on earth.